me to move back?
Yeah, that works pretty good. So I'll put this up here for everyone to see. So I'm at Western Ontario University, or University of Western Ontario.
Officially, it's Western University.
Oh, they
rechanged
it.
their name.
Oh, well, you can't do that. I mean,
They rebranded Western University.
Okay, so Western University here in London, Ontario. So I'm meeting with Dr. Clare Robinson and Dr. Ming Wu. So we're going to be talking about Great Lakes wildlife. Great Lakes. We talked about wildlife so much before this that I'm thinking about it. So we're talking about their Great Lakes research work. So if you want to get a hold of us, here are our Twitter handles, or you can also go to wildlifebiolgal.com to be able to watch the podcast, or listen to the podcast, or watch the videos afterwards. But it's best to get a hold of you via email, you were saying. So we'll get started off. We already got some users. If people want to let us know if you could hear us okay, if someone wants to give a quick shout out, and then we can also show off how the chat feature works. I always like to double check that the audio is working fine. So if someone wants to give a quick shout out there, type something up. As soon as they do, we'll continue on. You always assume that everything's working fine, but since you don't actually get to hear the audio at all, or maybe no one's going to actually say anything. So, you guys out there doing okay? I know you're on there. I can see you. They're all shy. I think that's what it is. We've got a bunch of shy folks right now. So, well, I guess we can continue on if everyone's going to be super shy about talking. But yeah, so Claire, why don't you start us off with,
Sure.
who you are, what your research is, what brought you here.
Okay. Sure. So my name's Clare Robinson. I'm an associate professor at Western. I'm originally from Australia, from Brisbane. I did my PhD at the University of Queensland. In marine environments, so looking at groundwater ocean interactions, so looking at the potential impact of groundwater discharge on water quality in marine coastal waters. I have been at Western now for 7 years, and since I moved to Western, my research has really transitioned more to look at inland coastal water, and in particular for the Great Lakes, looking at the potential of the contribution of groundwater and its effect on nearshore water quality. So whether that be, looking at questions, is groundwater delivering nutrients into the nearshore waters of the Great Lakes? What's the role of groundwater lake interactions in controlling E. coli levels, fecal indicator bacteria at beaches of the Great Lakes? So a lot of my work kind of comes from translating what a lot of the large body of work that's been done in marine environments to now the inland coastal environment, and looking at those groundwater coastal water interactions.
Okay. My name is Ming Wu. I'm a postdoc within Clare's group. I too am from Australia, but from the other side of Australia, from Perth. I did my PhD back in Australia a few years ago on environmental remediation of soils, but my background has always been groundwater modelling and development of modelling codes. So within Clare's group, I'm looking at using groundwater models to try and better understand bacteria transport onto beaches and how it's transported within the beaches. We also have projects looking at nutrients from septic tank plumes and modifying the software codes as well.
So I would say within my research group, we do a lot of field work in the summer, but we couple that with lab experiments and also numerical modelling. So Ming's essentially, he does help out in the field, but he's a computer modelling guy. So using kind of complex numerical models to actually understand how contaminants or bacteria kind of move in this environment.
So you're taking all that data and synthesizing it into something that we
Essentially,
can understand.
yes.
Okay.
Yeah.
Good. So why Canada? Why did you guys move to Canada? What made it, is it just easier coming here because it's part of the Commonwealth, so it's an easier transition for you, or was it just there was the openings up here that looked really interesting, or why travel all the way around the world?
Around the world.
Yeah.
It's a great place to be. Where else would you be but London, Ontario? Well, Western's it's a great university to work at. But I guess after my PhD, I left Australia. I spent 18 months at EPFL in Switzerland, and I did a postdoctorate there. And after that, I spent a year in Bangladesh, working with a water supply and sanitation NGO in Bangladesh. And after that, I had worked previously with someone at Western, and they were actually the initial reason I came to Western was because they were starting up a civil engineering international development program, and I had been working in Bangladesh. I had experience in research and academia, and so I actually originally came. I used to coordinate. I don't now. I used to coordinate that international development program.
Okay.
And so I came, and so that's what attracted me here, because they were building that program. And then once I came here and I started setting up my research program, there was this whole, I guess, opening in terms of these unanswered questions about what is the role of groundwater in terms of the Great Lakes.
Okay.
It's really, I think there's a lot of excellent researchers within Canada, looking at groundwater remediation, looking at transport of NAPL contaminants. There's less research, I think, involved in groundwater surface water interactions. So I think there are some very good researchers in that area as well, but there's a lot of unanswered questions in terms of groundwater as this source that people often don't consider as a source of nutrients or other contaminants if you've got industrial sites that are just sitting on the Great Lakes.
Yeah.
And so, it's been great because I've been able to transfer what I've done before and apply this in the inland coastal waters.
Okay. And Ming, what brought you here?
Me. I took a slightly different path. So I did all my education in my first postdoc in Australia, and then came out here. Essentially, this was my first posting overseas with Clare's group.
Okay.
It was definitely, I think at that point I was looking at possibilities within Australia and overseas, and this was definitely one of the best options I had.
Okay.
Definitely. Canada has a very good reputation in terms of groundwater research, in terms of the remediation network, so it was definitely familiar to me in terms of that.
Okay.
And then also just the opportunity to work with Clare's group. The beach zone is not an area that I've done much work in, but it's also a very dynamic zone that changes, that changes quite rapidly, but also it's quite an important impact in nutrient cycling and other things as well. So it's definitely a very good opportunity for me.
How was the transition from Australia to here? Is it fairly, similar culturally wise, and then how was the process of actually having to move out of country because a lot of folks in the U.S. we usually just stay within it. So some of the folks might be interested, how hard is it to transfer between countries if you want to go study in another country? Because you've got this great opportunity, but sometimes I think it might be difficult because you're going out of country. So how easy was that transfer?
Yeah, I think for studying, if it's for grad studies, it's, as long as the funding's available, it's relatively straightforward. We have at the moment, some of my PhD students are from the States, and I think it's a pretty, simple transition to be moving at kind of a graduate level. At a faculty level, I would say for me, it's been excellent in terms of my career because it has opened up a lot of different doors, and I never would have looked at the Great Lakes and seen these unanswered questions if I hadn't actually relocated to Canada. Otherwise, you're really focusing on the same kind of issues that maybe you're looking at for your PhD or thinking about for your postdoc. But I would say in terms of the transition, it is more. The first couple of years as a new faculty member, I'd say it's a little bit more difficult because you don't have a network.
Okay.
You start, and if I was in Australia, I know people at the Ministry of the Environment. I know people at CSO, like the research bodies there, or the different ministries or government agencies. When you move to a new country, you don't know. You have to work out what the landscape is.
Right.
You have to work out who does what, who has what kind of equipment, who you can collaborate with. So it takes a whole, it takes a couple of years to build that and to build up a new network.
To really be up and running and full speed.
Yeah, and to work out like what are the questions in this landscape. Like if in Australia the research, the questions are different, a lot driven by water quantity, whereas here, say within the Great Lakes setting, we've got a different set of questions and how can you adapt and modify your research program to answer those questions, and how can you, for a lot of grants within Canada, you need support, you need supporting partners, which is good because you're working closely with government agencies, but you need to develop those partnerships.
Right.
And so developing partnerships is really important, but it takes time.
I think I'm
Ming can
definitely,
talk from the
I'm definitely still in the process of trying to figure out who the important parties are and building up my own network contacts as well. So yeah, it's definitely been interesting. Just getting out.
And I would think too, just being able to put your face in front of their face and be able to get to meet and know each other and know who you're going to be able to work with and how to work with them, because everyone's got their own personalities and things like that. So learning how to adjust to each and every person and figure out, okay, these are the folks I can go and talk to get what it is that needs done. And so,
and I think these days, there's such a drive and a need for interdisciplinary collaboration that you need to work out who does things before you can even start initiating things, and who'll be, whether it's someone within the university or whether you're looking at other universities.
Yeah, because you're thinking the whole funding process and everything, you have to have that all set up so far in advance before you even go out into the field, and you need to know who it is you're going to be working with while you're applying for that funding. And so you're talking years ahead of time sometimes before you're actually putting your boots on the ground to do the work.
And also the funding body, like in Australia we have the ARC, which is kind of the main research funding body. Here we have ENSA. The programs are different. They value slightly different metrics. So you got to understand the funding landscape as well.
Okay.
And understand, so in Canada, often if a company can put $20,000 into doing research, you can match that and make that into a $60,000 funding grant. But you need to know what the mechanisms are to do that.
Okay. You're just going to be sitting out there in the wind with nothing to do and wondering, I've got time, I want to do research, who's going to help out?
I was fortunate though, because I do a lot of computer modelling. So I'd say in my first couple of years, even it's expensive obviously to go into the field and water quality analyses, it rapidly builds up, so you need to have funding for that. But in terms of computer modelling, you need a computer.
Yeah, that's pretty good. You're good to go.
There's a lot of great software available. You need a computer, you need money for a couple of grad students, and then as a new faculty member, you can
you don't even really need a lab. You can just throw them out here in the atrium and just say, all right, there you go, here's your office, and have at it. So.
But I guess it gives you that time to build up that momentum.
So speaking of water quality and stuff, exactly where in the Great Lakes do you do most of your research?
So we do a lot of what we do. We do work on Lake Huron. We do work on Lake Erie, up in Georgian Bay, further north in Lake Huron, and more recently we're doing work in Lake Simcoe as well, which is a large inland lake in Ontario, just north of Toronto. But we, it kind of depends what the problem, or we do work on the Toronto beaches if we're looking at, it depends kind of what the research question is. So for instance, for the work that we do looking at beach water quality, just as background, a lot of studies, over the last 10 years have shown how, so when you go to a beach and a beach is closed, or it has an advisory, that's because the E. coli counts are above a certain level. And in the last 10 years or so, it's been shown how E. coli counts are much higher in the sand and the groundwater than in the surface water, where the health units are actually taking their measurements. So we're interested in it because we do groundwater, coastal water interactions, and we want to understand why E. coli builds up in the beach sand and under what conditions it will be released. So for that, we do work on the beaches in Toronto, because they're often, in urban environments, so we can have higher levels of E. coli. But we also work a little bit out on Ippawash, which is a beach near here. looking at how, when you have how E. coli can be released from the beach sand during wave events or rainfall effects.
So do you think like the beach sand's kind of becoming a reservoir, so it's like being deposited there by the wave action brought in, and it's sitting there, and then it can be released back out?
Essentially.
Okay.
So it depends. Like some beaches where you've got really high bird populations, you can get E. coli just being directly delivered into the beach sand. But generally, I think in a lot of beaches, which particularly one of our beach sites, which is quite rural, there's not a lot of sources. So we think what happens is you've got lower concentrations of E. coli in the lake, and then it just recirculates, it builds up over time within the beach sand, so you get this reservoir. And there's kind of controversy over whether replicates or what happens to the bacteria in the sand, but then you have wave conditions that come through, so any wind, you get wind-driven waves, and that will mobilise and stir up the sand, and it will be released into the water, which will then cause an advisory. So it's an issue because it will cause an advisory when it's released. But the other issue is that that's where all the kids play, right? So you go to a beach and that's where you have kids playing in the sand.
Yeah, you gotta make your sandcastle.
Yeah. And that's where they eat the sand, and that's often the area
I remember
where
eating the sand when I was a kid. I'll have to ask my mom about that.
And the other thing we often find is that more sheltered beaches, which is often where parents will go with their children, because they're safer beaches because you don't have any waves or those beaches we often find higher levels in the sand as well because you're not having it more regularly being stirred up by the waves.
So it's just kind of settling there and staying there.
It settles there, it infiltrates in, and there's nothing that's kind of remobilizing it out.
Okay. Like with that, do you find that wildlife is more the problem, or is the urban population the problem? Because you can get E. coli both from humans and wildlife. So are you guys trying to differentiate where the E. coli is coming from, or are you just basically just going and seeing where it is?
No, we have done some microbial source tracking work. So I do work with a researcher in Environment Canada, and he does the kind of microbial source tracking. So looking at the human marker to see whether it's related to the human source. So that's part of it as well. And there's a lot of other, really great researchers in the Great Lakes as well who are looking at, other pathogens. So, we see E. coli in the beach sand. It's not necessarily a health risk. So are there pathogens that are there that and what's their behaviour relative to the indicator? Because that's a question as well. It's about, we use E. coli at the moment, is that
best way to track it. My lab, one of our former grad students, he was part of a dual lab project where we were more the wildlife side of it, and so we were using dogs to chase voles off beaches, and then the microbiology side of it was that lab they were going out and testing to see, what's the differences in the E. coli levels, where we've been chasing voles versus where we hadn't been, and so I haven't quite found out the full answer to that yet, if it actually is having an impact as far as the E. coli levels. I know that there definitely was a big impact with the number of voles that were there. It was pretty successful with chasing it off. So
they were just getting dogs onto the beach.
So they're like the dogs that they use to chase birds away from airports and other things like that. They're using that same kind of dog, and they just would go out and just harass the birds all day long. And so they were just sitting there on the beach for 12 hours a day and just letting the dogs go. And it was kind of funny. My labmate, he's got blonde hair, but he came back with hair that was almost like just the neon glow of yellow that just looked so weird after being out on the beach all summer long. But no, it's really interesting because you think of all the number of times that you have beach closures. I mean, that makes a big impact in the economy of those particular towns. Because along Lake Michigan, those are huge resort towns there, and if those beaches are closed, that has, just the daily impact alone, you're talking tens to hundreds of thousands of dollars that the economy just lost because that beach was closed. And so I think...
And I don't know what the current... There are statistics out there for how much money, how many millions they say it's worth to, say, the Ontario economy or the US economy, or... What was it? Is it 10%? No. I can't remember. There's a statistic for how much. It's quite alarming, the number of advisories that they do have on beaches. No one likes to, drive all the way out to the beach and there's an advisory. But I mean, they do have good apps now as well, where you can work out, you can look to see whether your beach is closed.
Oh, really? I didn't know about that.
But, but then the big thing with E. coli is you take the sample, it takes, 24 hours till you get the results, and everything's changed within 24 hours.
Right.
So when you have a beach advisory, that's because the day before the E. coli levels are high. It doesn't mean the day before that the current day the E. coli levels are high.
Yeah, so you could maybe have the wave action come in and
changes
either
everything. Yeah. So a lot of health units will, on maybe less popular beaches, they'll sample once a week. Okay. Whereas the concentrations are very variable over the week, so that's not, Okay. So kind of the new thing, let's say the Chicago beaches, they do forecast modeling. Okay. So or they have statistical models where they measure a whole lot of different environmental parameters, such as the turbidity, what the waves are, what the rainfall is, and they turn that into, we think there's a advisory, like they'll issue advisories based on running those environmental data through a model.
So you're basically correlating those different metrics to what should be a high E. coli count for that day, and thus being able to get that real time. Let's just put that probe in the water. All right, we've got these numbers. Yes, there's probably E. coli here. So you don't actually have to then go measure for E. coli itself and have to wait that 24 hours. You can right then say, all right, the beach is safe today. Everyone can come out.
And they have done a lot of, I don't know what stage it's in, but they've done a lot of testing in terms of, is the model, you can't trust a model, but is the model telling us what it should?
Is at least fairly accurate enough that we can tell the public that this is probably what's happening. Interesting. Yeah. So you also do lead water level counts?
Well, we do. So in London, a lot of municipalities, they have, the issue with high lead levels in the drinking water. Okay. So we do some work with the City of London. I think it was about 8 years ago. It was front page news, the high lead levels in the drinking water, because they had lower pH. So when you have lower pH, the pipes are a little bit more corrosive, so you get high lead levels in the drinking water. So we do work where we've been working with different municipalities in Ontario to look at how we can change the pH or the alkalinity or different additives in the drinking water treatment plant to reduce the lead levels in the drinking water.
Yeah, because I know being from Michigan right now, we have I don't know if you guys heard about Flint and the whole issue.
In everyone?
I was assuming you guys heard too, but sometimes it's interesting to see what translates across the board that makes big news over here. I always listen to the EC Radio Canada out of Montreal, just so I can have fun trying to see what's the big news that's going on over here. Is it really important, or is it just the American news stations blowing things up?
No, well, I was in Australia and it was pretty big news there.
But so I mean that's a big issue. So how did you guys kind of manage that here in London? Was that how long did it take you guys to be able to get back and have the public's trust back from the lead levels and because what Flint happened within this past year? So how long are we kind of?
Yeah, well, I mean Flint was a much bigger thing than London, Ontario. It was before my time, but I mean they definitely, as when it was front page news, but it probably took them a couple of years to really recover the trust. But I mean they've changed the pH levels at the treatment plant. Like it's very and they have a lot more routine household testing now.
And do you guys get to do part of that, or is that all in house with the city? Doing that kind of testing, or do they ask the university to help them out or so?
We help them, myself and another professor that's at Western. They run pipe loops. So in their pump station, they had pipe loops where they run. So they pull out lead pipe out of the ground. You have to be really careful with how you pull it out. And then they set it up and they run experiments looking at if we run at this pH, what will that do to the lead level? If we run it, and you see seasonal effects where you get higher lead levels in summer compared to winter. So we help them analyze that data. And we ran some kind of just simple water quality models showing how changing the pH or the alkalinity would do this.
Okay.
Yeah.
All right. So you also do green roof work too.
Yeah.
So talk about that, because I really like the idea of anything that helps the urban setting become a little bit more green, and also sustainability too.
Yeah.
So tell us how green roofs work. Why are they good, and then what actual research you guys are doing with them.
Sure. I mean, so green roofs are, green roofs have been, they're very well, like somewhere like Germany, it's been, they look at us now studying green roofs, and they were all over 50 years ago.
Okay.
But I mean, green roofs are, I guess, an increasingly popular kind of low impact development tool for probably the big driver in Ontario anyway is for stormwater management. So somewhere like the city of Toronto has mandated that buildings, commercial and industrial buildings over a certain size, they should have a green roof. If they don't have a green roof, they have to have other ways to manage their stormwater.
Right.
So essentially green roofs, how they work is, in terms of the benefits they provide, is that they provide a storage within the roof. So when you have green roofs, obviously a lot of people, when they think of green roofs, they think of, maybe large vegetation and gardens on roofs. Green roofs are often just a very low-lying canopy of a vegetation. Sedum's probably the most commonly used green roof.
Okay.
And what green roofs do is that you've got available water storage within the soil. So in your garden, when it rains, the water will infiltrate into the soil and it will be stored within there and not directly released.
Okay, so you're not having that hardcore runoff that could cause storm events.
Yes,
where you have the flooding in the city streets.
So if it rains and it hits the car park, it just runs straight off. Okay. Whereas when green roofs are trying to restore an urban environment back to its previous, rural conditions. Okay. So when it rains, the water's stored within the soil. Okay. So and that reduces the peak runoffs that you see after a storm event. It delays the runoff. Okay. So rather than everything hitting the drain, the network straight away, it will delay that runoff process. So that's one of the benefits of green roof. The other benefit of green roofs is reducing the heat island effect. So the thermal benefits in terms of green roofs, because they evapotranspire the water, you get a heat that's lost. So basically they have a cooling effect on cities as well. So that's the other main benefit of green roofs.
Like, how much of an increase will you see in those heat islands, say being here in London versus if you're 10 miles out of town? Like, what kind of differences are you looking at roughly? I mean,
I don't
I'm not
know
looking
what
for
the numbers
exact
are.
numbers.
Yeah, I don't. We work with an excellent kind of urban microclimate guy, and he would answer your question directly. But I don't know in London, but somewhere like City of Toronto, it's, they look at how, the microclimate around the city can change, the weather patterns around the city. Okay. Yeah. And the work that we do is, we had a large green roof grant. We have a few green roofs around Western.
Also across the country in different climates as well.
Yeah, but as I say, we have green roofs here. We initially kind of started off as student projects. We got a larger grant and we set up 3 identical green roofs in different Canadian cities. So to look at, we had a green roof in London, we had a green roof in Halifax, and we had a green roof in Calgary. So very distinct climates within Canada. So Calgary, super dry.
Prairies close to the mountains there.
Yeah, but it's very dry. They get large precipitation events earlier in the summer. Halifax is more your maritime climate, a bit drizzly and cooler temperatures.
A nice little middle temperature.
And so we set up the identical green roofs in all these 3 cities, and looking at how the stormwater benefits of green roofs compare in these different climates, how the thermal benefit, the kind of the cooling benefits. And then we have, there's a lot of different design parameters when you're looking at green roofs, like how deep the soil media is, what type of plant you use. A lot of green roofs, some green roofs will be flat, other people will install green roofs on sloping roofs. So we were looking at all these design parameters in the different cities to see how, how these, the stormwater benefits of the green roofs.
Yeah, so what combination works best to help control that runoff?
Yeah. Okay. And a lot of it from our work, a lot of it comes down to how much evapotranspiration we have.
Okay.
Because if you don't have evapotranspiration will remove the water, so you then have water available in the soil for the next storm event.
Okay.
So if you don't have evapotranspiration, you don't have the cooling effect, you don't have as much water storage that's available in the system.
All right. So talk to us a little bit about the modeling you do. Like, how do you go about that? Like, I don't really do a lot of modeling. I'm just out in the field and crunching numbers and just kind of throw it all out there. So explain like exactly what it is you're modeling, how you do that.
So we use commercial groundwater modeling packages.
Okay.
But essentially it's trying to tie in the physical groundwater flow and recirculation patterns that you get from the lake water infiltrating.
Sorry. Is there a Tim Hortons here normally, or an ATM or whatever? I'm searching for an ATM actually.
If you walk down the main road straight, there's an ATM there, and there's a Tim Hortons there.
Okay, thanks.
That's a very Canadian question.
Yeah.
Where's the Tim Hortons?
Yeah, I told my mom's traveling with me as we're heading to a wedding in Maine, and I told her like we can't go through Canada without going to Tim Hortons.
Yeah.
We have Tim Hortons in Michigan, but there's something about going to Tim Hortons actually in Canada that you just have to do there. It just tastes that little bit better for some reason.
Oh yeah.
So yeah, I know it's all mental, but it's just it just for some reason just has that extra special. I think it's just because you feel good because you're actually going to a Canadian Tim Hortons rather than going to the Michigan Tim Hortons.
That was just funny because that's such a Canadian.
It is.
Oh, Tim Hortons is in every building, maybe every third building on campus they have a Tim Hortons. Like long lines every day.
Yep. Well, in Massachusetts, you go there and you have a Dunkin' Donuts on every corner there. So yeah, you will not miss it for sure.
Yeah.
But no, sorry, go ahead with the
No,
model.
that's good. So it's really trying to tie in and understand how the physical groundwater processes and also that infiltration for lake water onto the beach and recirculation patterns within the beach affects the bacterial transport. So so we use standard groundwater flow and transport equations, but we also tie that in with colloid filtration theory equations, which have been used quite widely to describe bacteria transport, but also other colloids like nanoparticles that are used for remediation. Potentially you could use it for microplastic work as well. But yeah, we've managed to use that quite successfully in matching what we measure out in the field as well. So it's been quite successful so far. So for the work, and then we can use that model then to try and modify simple physical parameters like beach slope or the groundwater gradient on land, and see how that affects the flow and transport processes within the beach and the bacteria build up over time as well. So yeah, so it's really just trying to understand the underlying processes that affect it.
So where do you guys go for conferences? Like, where can people, actually hear you guys talk about your research? What conferences do you normally go to?
You have your favourites.
We do normally. We often will go to the Great Lakes Beach Association conference.
Right.
This year, it's been held up on Lake Superior. It's up in Michigan, North Michigan. So we will every year. We generally will go there. It's a really good conference in terms of beach managers, health units, different government organisations. It's a bit more of I would say a practical conference. People are there, they've got problems on their beaches, they're trying to look for solutions. So every year we'll go to that conference. We we try to go to IAGLA as well.
I'm a big fan of IAGLA. In fact,
I'm
even sporting their water bottle right now.
And then we, we'll internationally, if there's national conferences that are close, we'll always try and attend them, like the IAH, so the Hydrogeologist, International Association of Hydrogeologists will attend, because we kind of work at that interface between the Great Lakes, but we're also working with the groundwater hydrogeology community. And then internationally, we'll generally go to the AGU, which is the American Geophysical Union conference meeting in San Francisco every year. It just depends what comes up. Like I was recently in Australia at a conference, which is a kind of coastal aquifer management swim conference.
All right.
Yeah.
I would say that's the typical conferences,
Not bad. So, in your field, like I noticed that you guys both have engineering backgrounds. Is that the usual standard for getting into doing water quality? Like, how did that background help you guys with jumping into water? Is it more like,
No.
I'm coming from the wildlife biology side of stuff, so it's like, some of these questions, like, I don't know because I don't really do a lot of water quality. Like, the only thing I've done is stuck a Y-side probe into my water, and it gave me some readings, and I'm trying to understand that, but that's definitely not my strength of anything at all.
No, it's a good question. So I would say our research really sits in between engineering and science.
Okay.
So you would have researchers that do similar to what we do, but they might be in, earth science. Or, you can have hydrologists that look at how water flows, but they might be in geography.
Okay.
Right? So I wouldn't say we're not traditional engineers in terms of we build things and we're trying to develop this particular process that's, green roofs is different because then we are looking at, engineering design parameters. But I think we really, in terms of environmental engineering, where we come into it is that we're using a lot of applied math, particularly when it comes to modelling. So developing these computational and numerical models these are skills that we learn, within engineering. So, so at an undergraduate level, I teach numerical modelling for environmental engineers, so groundwater, surface water modelling. So it's really perhaps the field work we do could be engineering, it could be science. Once you get to a research level,
it just kind of blends together.
But I think, in terms of the engineering, it's really once we're developing these computational models, and then a lot of quantitative analysis of the data rather than, and trying to really understand, say when we're looking at bacteria transport in beaches, really trying to understand what are the fundamental, like how is the flows interacting with the bacteria and the bacteria transport to, understand through the model development.
But in terms of students, I think we've had both environmental science and environmental engineering students' backgrounds as well.
Well, I think you need that. Like, no matter what you're in, it's nice to have those outside thought processes coming into something. Because my advisor, he's more of traditionally an upland wildlife guy. Like, he studied wolves, he did weasels, and that was his background before coming in. And then within the last 5 to 6 years, he's gotten into coastal wetlands work because we got a big, huge grant that came to CMU, and there was some bird and amphibian work with that, and so they're like, hey, come hang out with us and do that. And so now he's jumping into all this coastal wetland work where for him, at first it was, what can I bring to that? But he's got these different thought processes that maybe coastal wetland scientists don't necessarily have, so he gets to bring in that unique thought process, and so now you get to expand that science in coastal wetland because you have that different thought experience. And so I always like that when you can blend things because you can think so much more outside the box and stuff and hope to find solutions. So.
Well, it really is when you're talking to people, often when you're talking to people, in another discipline that, or, they might, I'm traditionally, I say a groundwater person, but when I'm talking to people that do surface water, and they might take time series of, let's say, water levels, and the way they analyse it is different to what we might do in groundwater, but that's when you can actually get, let's see how they do it, and I'm sure that we can apply it to what,
So talk to me a little about what Restore is, so the work group that you guys have here. So there's a couple other professors that are in that?
Yeah, so there's 2 other professors, Jason Gerhardt and Dennis O'Carroll. So Restore is our research group within civil and environmental engineering at Western. Really we looking at anything related to groundwater, contaminant transport, remediation of contaminants. And we try to create, a cohesive research group environment for our grad students to, because Jason Gerhardt and Dennis O'Carroll, traditionally they're probably more, not now, but, they do groundwater remediation, contaminant, like groundwater contaminants move in aquifers. I mean, now they do what, Dennis works in green roofs or in other areas, but it really, we find it really beneficial. We work together, we share our labs, and our graduate students share ideas. So even though more of my students might be working on groundwater, coastal water interactions and things related to the Great Lakes, other students who might be doing a groundwater remediation field trial might be using certain field methods that match together. And then we have weekly research group meetings every week, so the students can take turns presenting ideas and presenting their thesis.
I think it's
social
also,
events.
I think it's also been very beneficial for the students to be within that environment with different projects going on as well. So some students from the beaches group have had experience on the field sites at the remediation sites as well. So that's definitely a plus for the CVs. An experience.
So for the students that might be doing numerical modelling, they have the experience that they can go down to an industrial site to spend time in the field learning, how we do groundwater samples, how they set up a groundwater remediation system in the field, but then they can also go to my field sites and look at, how we do groundwater surface water interactions and really get hands-on experience, because, when we're in the field, often it's all in, everyone has to help out. But it means that then when they're applying for jobs, they have a much wider understanding.
And they're more likely, more open to different jobs and that they might be able to apply to.
Or my students that are working on, say one of my students that might be working on fecal contaminants at beaches, so looking at E. coli at beaches, because she's been part of our Restore research group, she understands about groundwater contaminants and different organic contaminants and different remediation technologies, which is much broader than if I just worked in an isolated group.
So it expands it out a little bit more. We have a little bit of that at CMU where we have different labs and we're collaborating. We do the lab meetings with multiple labs together just to help, because some of those labs are smaller, and so it's nice to be able to have that larger community that you're a part of. Without it being the whole entire department, there's no way that you would ever get through a meeting if you did something like that. You can have those little select groups within the department that are somewhat related.
And I think, and particularly I think for students, graduate students who are moving in from out of town, it's like a lot of our students, our graduate students, are not from London. So it creates an environment where they can come, and it's almost like they kind of have a family story. They have people that they can.
No, I mean, it's very important. We have a number of students from out of state that come to Central Michigan, and so to be able to have that sense of community while you're there is so important to help you get through. Because if you're happy, you're going to do a better job, and you're going to do better research, and so it benefits everyone. So having that sense of community is so important, because you don't want to just be that lone person in the lab, because you're just never going to get through. You're going to be, why am I here? But if you've got those people around you to support you and help you out, it just, the science and you just blossom, and it's neat to see people grow through their grad student experience because of that.
Because I think that the experience students have through their grad studies is really important for also for training, like whether they like research or whether, and a lot of teamwork is required as well. Like when we're going into the field, we might have, some days only 5 people, some days it's 10 people, and it needs to, you all need to, you've got your own research project, but I think everyone knows that they are working as part of a team.
Well, and I think it helps too. You are setting up network connections that you have, because once you leave here, you're going to be at different universities or different agencies, and so you have those people that you can pull on and say, "Hey, I've got this project. I know this is your specialty. You want to come help out with this?" Or they might say that to you, and so it allows you to maybe have those future collaborations with people. So you already have that network help set up. So when you have to go start fresh at a university, you've got those people that you might be able to call on and say, "Hey, I want to be able to start this here. I know your specialty with this. You want to come help out?" And I think that's one of the big reasons I've had people tell me why it's so good to diversify your education at different universities, because that way you can build that network of people and have those different communities that you can pull on when you need to later in life. I guess the last thing I'm going to ask, and then I'll open it up for questions for the viewers that we have, is tell us a little bit about Western here? Like, how is the university, like, tell us about the program here that, you know, just like the overall branch, how is Western, you know?
Yeah, I mean, so Western is, it's one of the, I guess, research-intensive universities in Canada. We have all the different faculties, you know, within law, science, music, the business school, engineering. Engineering program has one of the lowest student-to-faculty ratios, which is really nice. So I think Western always does. I think it always tops out as, you know, having the best student experience, because you know, it's smaller class sizes, you know, a really nice campus, you know, for students to be actively involved in different activities, and but you know, it's a smaller university than say UFT, but it's a nice university because it's very compact and close together, and all the students getting residence in their first year. You know, but I think from a research perspective, there's a lot of you know, excellent researchers, very, you know, good research services to help develop any, you know, ideas that you might have or any proposals that you put in. Yeah. So in terms of engineering, we have all the main forms of engineering, you know, chemical, mechanical, electrical. How does it compare to, you know, I mean, it's from UQ, which University of Queensland, where I was in Australia, I would say it's a smaller university, but it has everything. Yeah, it has all the facilities. It has great facilities, great labs. You know, particularly in Canada, I would say we have incredible infrastructure funding. Yeah, so it's you know, through the CFI grant program, it's quite remarkable how the amazing infrastructure that we have. You know, within you know, civil environmental engineering. So, for instance, we have a lot of strength in wind engineering. We have a windy dome where they can basically simulate tornadoes and downbursts, and so, you know, it's really a world-class facility, and it's only possible because we have this incredible infrastructure funding within Canada. I mean, I don't know how it compares to UWA. I mean, it'd be smaller.
Yeah, it is, but it also has, I mean, for its size, it also, Western has a very good reputation in terms of its engineering research. Work.
And there's a lot of people within environmental engineering, within chemical engineering, that look at different water, whether it's water treatment, wastewater treatment, whether it's looking at water quality and the environment, groundwater remediation. There's a lot of strength here within the water area, and then also, you know, in biology or in, you know, a lot of, or in geography, people working on, you know, Great Lakes water quality issues as well.
Well, we've got some users there, so if anyone has any questions for Claire and Ming, go ahead and start sending those in, and feel free to ask anything about Great Lakes, groundwater, E. coli, green roofs, anything about the university here, Western Ontario. They're open for pretty much anything. So, give them a few minutes to see what questions they can come up with, or if they're going to be shy. And if there's more intensive questions that you want to ask, that you feel like maybe it's something we won't be able to answer through Periscope, also feel free to either tweet us at our handles, or with Claire, it's better to email her. So our first question is from, let's see, Science in Michigan. Hey guys, really enjoy learning about your work. How do we better predict E. coli advisories?
So I guess there's a lot of work that's been done looking at forecasting modelling tools. So, you know, I think that's probably where either we need faster ways to analyse when you know, people go out and they take the water quality measurements. But I think, you know, building these, or they've had a lot of success, I would say, in terms of these statistical regret, these models that they use, where they can put in a wave buoy, look at what the currents are, look at what the rainfall is. And so I think really the continued development, which getting these models right, you need data. And so part of it is getting data for a particular beach, and then training these models for your particular beach. You'll get the best results.
So you just need those long-term data sets to really be able to fine-tune that model.
Yeah.
So.
And that's probably, I think, at the way that's kind of the state of the state of the art at the moment in terms of you know,
Okay.
recognizing that when you take a water quality measurement, it changes the next day. But if we can get these forecasting models working, it's,
Right. That way you can have better predictions.
Yeah.
And then also, like, once you have those predictions, then maybe you could figure out ways to help combat it at those times if you know those are going to be really bad times for people. Like, okay, what are the instances of calling that, and how do we stop that from happening? So, question from Science in Michigan: how do you think deploying these models to the public might work?
well, I think I mean, they do. It's about something like apps. Like, I think that I'm not. It's not really my area, but I mean, they do have. So you might have the models, they get run automatically, but then they can send the results out through apps to say, this is, you know, we think that at the moment there should be a beach water quality advisory, or the E. coli levels are high in the surface water. So I think, you know, there's so much technology now to get the information out to the public, and they are using that, definitely. I think the beach water quality community has been quite successful, particularly in the States. Less so, I would say, in Canada.
Okay.
Like, it's saying that in the States they have much better dissemination tools in terms of the apps that have been developed. I think it's taking time within Canada to develop that.
All right. So definitely might be. Another question from Science in Michigan: will your work be able to decrease that 24-hour turnaround on alerts?
Well, I think the predictive models will. Our work will. The work that we do is perhaps trying to understand E. coli buildup in the sand is a little bit more fundamental, because we're trying to understand why is it that waves are increasing these E. coli concentrations, which can be then used to improve these predictive modelling tools. But it's these predictive modelling tools that will improve the 24-hour turnaround, because you're measuring what the current environmental parameters are, or, you know, what they were the last 24 hours or 48 hours, and you use that current data to say this is what we think is happening now.
Okay.
But then there's a whole nother suite where people are trying to get rapid detection tools, and that's a really important area as well.
Yeah, it seems like those apps are becoming the wave of their future. There's a lot of invasive species reporting apps that are going out now, and that seems to be doing really well. Like, every state seems to be developing their own reporting app. And so what's nice about that is, like, you can have people take a picture of the animal, send it in. It also has a GPS point, so you know exactly where to go out if it's an animal that you need to, like, go address it right at that immediate moment. And it helps them verify rather than, like, say, like, you know, I study mute swans. Most people can't quite tell the difference between a mute swan and a trumpeter swan, even though it's got that bright orange beak. But once you know, you know. So the mute swan's got bright orange beak. The native trumpeter swan has the all black beak. But if you don't know that, you're just saying, I just saw a white bird, I think it's, you know, an invasive bird, and you go out there and like, no, it's not. Why do we just waste that time going out there to do it? But by having that app and being able to see it, then you'll know for sure. So.
But it's also a lot about, I think these apps are slowly being developed, but people have to, it's about disseminating that these apps exist. Like, there was some recent app for Ontario that I did an app or a website, and I didn't know about it, even though I've been working in this area. So it's about, people have to know, and then you've got to have the avenues to disseminate it to the public. And that's where grassroots or NGOs that are working on the front line with the beach communities are so important, because they're the ones who, on the ground level, are the ones saying, hey, you should be using these apps to work out.
Yeah, I mean, like, something that really simple that I was exposed to yesterday when I was at Wayne State University talking to them. Like, they handed me these invasive species playing cards, and here, I'll ask the question real quick, I'll get back to that. Does Western University have researchers working on predictive models alongside your work with accumulation? So we'll answer that in just a second. But anyways, it was invasive species playing cards, and so they hand these out to the public, so it teaches people about these invasive species to be on the lookout, because it's the watch list of what could be coming into the area. It's such a simple way, and I think you could do things like, you know, it's such simple ways that you interact with the public to help teach them about stuff. So there's got to be simple ways to be able to let them know about these apps, you know, where not it's, you know, maybe just putting the ad out on Facebook or something like that, so people see that, you know, as they're scrolling and things like that. So, but
So are we using, at the moment we're not, we don't use predictive models per se, we're more looking at more the fundamental processes and trying to understand, well, is this beach more likely to accumulate E. coli within the sand? Is it more likely to be a problem here? But in the future there are certain findings from our work that we would like to, I think, work with other researchers who are doing predictive modelling in terms of saying, okay, we now understand that, for instance, if you have had very calm conditions for 5 days and you have a wave event, that's going to lead to high water quality in the surface or high E. coli levels in the surface water compared to if you have regular waves occurring at that site. So that kind of information can feed into predictive models. We don't do it per se ourselves at this stage, but I think in the future we'd like to work with people that do to try and help them put the work that we're doing into those models.
Okay. Any other questions out there? We've got Claire here for a couple more minutes before we have to let her go because she's very busy today. She's got other researchers visiting, so I could only score her for about an hour here. So if you've got any last questions you want to ask, now's the time. Otherwise, you can get a hold of us after the Periscope.
I mean, you can always email me at any time. Happy to answer questions.
And definitely check out their the Restore website online. It's a good place to get information about the work that you both do. Seemed to be a pretty robust site when I was stalking you guys online before I showed up.
Yeah, so it encompasses everything our research group does in terms of the groundwater remediation work, the different remediation technologies that Jason Gerhard and Dennis O'Carroll are working on. Because I mean, our work is really quite broad across the groundwater
spectrum.
Yeah, spectrum.
Okay. Well, with that, if there's no more questions, I'll wrap things up. So I'll just put up the Twitter handles for everyone again if you guys want to grab the screen grab of that. If you didn't catch the whole broadcast or you want to be able to listen to it again, you can go on to my website at wildlifebiogal.com. There's the links to Periscope, YouTube, and podcast. This is from Science in Michigan, not a question, but thank you for your time sitting down to talk and share your work. So yes, thank you both very much. But yeah, so go check those out. I will have the podcast up within the next day and YouTube probably also within about the next day too, so you guys can get those links. And then of course, now that Periscope lets you actually have the videos up for more than 24 hours, you can always go see the video on Periscope there too. So with that, I'll thank you guys both, and we'll be signing off, and see you guys all later.
Yeah.